So what I'm going to do here is a few things. The first, well, I guess in summary, we'll be building just a simple predictive model, very easily updatable with data that we're going to download from the Federal Reserve. But essentially, we're going to build a model that just forecasts sales for a fictitious company based on price, the price they charge for their product, and then an external indicator. For this, we're going to use our GDP per capita as a proxy for income or wealth. So the first step is to download the data from the Federal Reserve. They have actually a very friendly API that you can use. This represents the series ID for our GDP. And then this, in this input tool, is basically, this is the API key, or has my API key and then the API URL. What we're looking to do here, I'm just going to append them. These are two different API URLs. One just has the series info, like the interval, if it's quarterly, if it's in billions of dollars, so on and so forth. And then one actually has the observations. So first, we're just going to use a formula tool to simply replace series ID with our series here. Now, the way I have this set up, it's very easy to just add more series IDs if you want to download multiple at one time and compare more than just our GDP. I mean, we have modules that download hundreds of thousands of these indicators at one time. So now we have our URL. You can put this in Chrome, you can see what the data looks like. Okay. So that's just the series info. Like frequency is quarterly, chain $2,009, all that information. And then this one, the actual observations. So there's all the data, dates and the data. And we can see, not only from this link, but the format of the data, that it's JSON data, which is very friendly when using with Alteryx. So what we'll do is simply just put a download tool in here. And we'll download based on URL. We'll just pick our URL field. And that's really all you need to do in this situation. We'll just pick that and then we'll press run. And then this is the data that comes out right here. Each one of these cells contains the series info, and that contains all the observations. So next we're just going to parse that out using a JSON parse tool. So just plop that in there. And you can see it automatically parses out all the rows for us. So you can see all our info over here. Now we just got to do a couple more parse, or one more parse on the JSON name just to break this out. So we'll parse again on just period. Then we'll break out the names here. So we're interested in the series info, which starts with series, and the observation info here. So we have our date and our value is really what we're interested in. So we're just going to transform this data. So what I'm going to do first, I'm going to filter on observations. I'm going to filter the observation data from the series data and transfer these very similarly. So I'm just going to unselect some of the stuff I don't need to see. And then I'm going to transpose it. So right now I have just my series ID, my value, my record ID, which was in the JSON name, which is going to come in handy here, and then the name. And what we want is this, we want these in the columns, basically. So we're just going to transpose it. So we have our transpose tool here. I'm going to transpose in series, record ID, and then I want my new header field to be name, and then the data field to just be the value. And now you can see our results here. So we got date, we're really interested in date and the value. What we'll go ahead and do is just sort by date, And then I'm just going to deselect some things that I don't need. So now we have nice, clean, vertical columnar data. The data has to be in this sort of format if we input it into predictive tools. And then down here, I pretty much did the same thing for the series data. So now we just have information regarding this indicator, this quarterly. You can see the stats that come along with it. And now we'll just join the two. So every one of our rows of data just has its series information. Okay. So now, ideally, we just run this. If this comes out quarterly, some indicators come out monthly, some daily. You can just either schedule this to run daily, weekly, monthly. The model will automatically update. You'll see once we get to the predictive stuff, the coefficients will update as the data, as more historical data comes in. So we're just going to deselect some things and see. Now, you'll notice that this data is quarterly, and our internal KPIs that we're going to overlay with this data, those are monthly. So we're going to interpolate this quarterly data into monthly data. Here, this isn't really necessary, but I have just a filter tool that's filtering on the frequency for quarterly. Say I'm downloading multiple indicators, one that's annual, one that's monthly, one that's quarterly. I can set up different processes that interpolate those differently. Or you could probably do a more massive if statement. So to interpolate this into monthly, first we're gonna just generate rows. So we're gonna generate 3 rows per quarter, 3 months per quarter. So we're just gonna use the generate rows tool. Pretty much just set this to the default settings. We're just going to create a new field called row count, and we just put here row count less than or equal to 3, and then we want this to loop by 1. And you can see now for each observation now represented 3 times. 3 times. You can see our new row count field over here. So now, just for demonstration purposes, I'm going to get rid of the data that's being duplicated. So you can see these nulls are what we want to interpolate. So we are going to use the multi-row formula to do that. So this is actually fairly simple. We're going to create a new field called value2. You could do this in value, but for presentation purposes, I'm just going to create a new field. And what we're going to say here, so if row count equals 2, we have over here 2, then it's going to take this value minus that value, divide by 3, and then add that value. So you can see over here, there's our interpolated value for the first month between those 2 months. And then you can do this in one formula, I can split it out into 2, and now we have the same concept, our interpolated values. Exactly. Now, it's a good point. Some of these quarterly indicators are interpolated, so we basically look at this methodology where we just interpolate between 2 values. Some like indicators like, say, quarterly income that you get on 10Qs. Now that's a total for the quarter. You're not really supposed to interpolate between them. You can divide those and spread them out. For this, we're just going to interpolate. But now, last thing we need to do is get our months correct over here. Because now we just have our quarterly dates repeated 3 times. So we're just going to use another multi-row formula here. And basically all I'm saying is that if row -1 is empty, then take the date. This ensures that it's always going to take just the first date, because there is no row -1 here per date. Otherwise, it's going to add. So you can see our string. And what I did here, if you notice in all these multi-row formulas, I grouped every one of them by title, which is basically just this indicator right here. And we need to do this if we're downloading multiple series of data. If I have 5 different series, we want to make sure that we have that checked. Otherwise, it's not going to interpolate correctly. It's going to be interpolating between 2 values of different indicators. So I have a filter here. I'm going to filter out the nulls because down at the bottom I have a couple extra dates that don't have data because my interpolation, the RGDP only goes through April of this year, and when I added the dates, I had the text in a couple of screens. So I'm just going to filter those out. Now we can join with our internal KPIs, our sales and our price data. Notice this is just an Excel file with date and then sales and price. So we'll join the two. And before we feed them into the regression model, what I'm going to do, I'm going to convert these to log. And you can do this for several reasons. If the residuals have a skew distribution, if you want to linearize the relationship. But most commonly, and for this reason, too, we're going to use it to simplify the interpretation of the results, which we'll get to. So we're going to feed this into just a simple linear regression here. We're going to take log of sales and just convert it. That's what we're trying to predict. And we're going to use value log and price log. Value is the RGDP. And then price to try to predict sales. And here are our results. So we can see the asterisks. These are all statistically significant, notated by all these asterisks here. You can see our model fit is pretty good. We have an R-squared of 1.6. And we can see that the model makes sense. So value log, our proxy for income, has a positive relationship. And then price has a negative relationship. As you increase price, sales go down. Makes sense. Also, when we convert it to log, this makes this pretty easy to interpret in percentage form. So, for example, if we increase, or if income increases by 1%, then sales will increase by 2.45%. And same here with price. We increase price 1%, sales will go down 0.45%. So now what we're going to do is just feed this into the score tool. And this is simply just going to output our model values for every date. So there's our model value. You can see there's our actual value. And then here's our model. And we just want to, I wanted to output this because we're going to feed this into Tableau so we can actually visually see the model versus the actual sales. But first we have a branch off here. And I downloaded this tool from the Alteryx gallery a while ago, and I use it all the time. And it just provides the coefficients of your regression. And what we can do is we're just going to transpose these here, and we're going to feed it right into Tableau. And I'm going to use these in an equation in Tableau to generate our dynamic Y. So now we'll simply come out of the score tool with all our data. This is just a formula tool taking the inverse of the log and converting them out of log now by just taking exponential. So you can now see that sales are back to their normal numbers. And before we join, we're going to join some data over here that we branched off. And basically what we're doing, we branched off over here because in our Tableau workbook, we want to provide some forecast dates. So we can put basically just a forecast dot out in the future, which we'll see in a minute, that moves based on assumptions the user gets to make. But first we got to add forecast dates to the database. So we'll simply do that. First, we're going to find the max date of the historical data. So we have price data, sales data, and GDP data through April. Say we want to generate a 24-month forecast in Tableau. What we're going to do is just add 24 days, or 24 months. So we're going to calculate just our max date forecast by just doing a date time add here. So we have date current, and we're just going to add 24 months. And we're going to use the generate rows tool again to generate 24 rows. So here we're basically just generating if row count is less than or equal to pretty much 24. So I'm taking the date time diff between date forecast and date current. So I now have just an extra 24 rows. And then one last step is to convert this date into a sequential date, interpolating between that and that. And what we're going to do is just simply date time add our current date plus the row count index. So now we get all our dates out 2 years. And you can see we're just going to unselect a few things and rename them. And you can see us now joining our new forecast dates, our 24 rows, with our historical data. You can see that down here. It ends, and we just have no values when we have our dates. So one last step, what we're doing here is just appending each row with some statistics that are going to help me create formulas in Tableau. And just make my life a little bit easier in Tableau. Now you can definitely do this in Tableau. I just prefer to do this stuff in Alteryx first because it makes life a little bit easier when creating formulas. So what I'm doing here is just appending the current value of each metric to the database. So you'll see why we're doing that in a minute. So now you can see, like as of April, the most recent date, our GDP was 10.8, and price was 1.9. And we'll just append that to each record. You can see over here. It's just repeated over here. So now we'll hop over to Tableau. Okay. So this is just our price. We have our historical trend, and we have our forecast dot out here. Now I've went ahead and made this dot dynamic. Right now it's set to just a year forecast, so if they want to do a 1 year forecast, they can just set it to 12, I can crank it out to 24 and see it move back and forth. And that was pretty simple. Ooh. Basically all I'm doing there is take the date time add, month, a forecast month, which is that parameter I created, and then plus the date current. See, that's why I appended the date current. It just makes life easy. So now, but this dot is generated using this formula right here, this price forecast formula, which is dependent on another parameter. So you can see that, if date equals forecast date, or date forecast, we wrap this in exponentials because these are log values, so we got to take pretty much the inverse of these to get out of log. Then we're going to take price log current, which we appended at that last step, plus what we want to grow price at, or what the user wants to grow price at in this dynamic model. So you can see right here, the price parameter, if they want to grow price 2%, you can see that. Now I did the exact same thing for our GDP. Okay, first, let me set this back to 0. And then those are going to be feeding into our sales forecast. So you can see the green, these are the actual sales from our database, and the red is the modeled sales from that score tool. And what we did to generate this dot is we use the coefficients that we fed in from Alteryx. And you can see I have another extract right here, which just has the values of my coefficients. So my intercept and price and RGB coefficient. So I come back here and open up the sales forecast. You can see this. Okay, so same thing if date was date forecast. Now I had to aggregate these, so I just put them in. So this is our intercept. It's wrapped in exponential because it's log. So we have our intercept, and then plus our coefficient for price, and we're going to multiply that times the current price plus how much we want to change the price. And we do the same thing for our GDP. We have the coefficient plus the current value plus how much we're going to change. So you can see, if we leave these at 0, it represents no change. You see it outputs the most recent modeled value. So 610.4, and you can see what our dot is, 610.4. Now I made this simple dashboard so you can kind of see everything on one sheet. So for example, if we think price is going to increase 2% or 2.3%, which seems like a reasonable trend. And our GDP is going to increase 1.5%, which also seems like a reasonable trend. You can expect sales to be 628.2. It's pretty cool. Yeah. Now you can also use Alteryx tools. I always like to leave the ability to override and do what if, but you can also use the Alteryx time series tool to forecast these automatically for you, which is really powerful. And that is about it. Anyone have any questions? Did I bore you to death? All right. Well, I'll be around. So if you want to dig in a little deeper, I'll be happy to go over this.